Okay guys, sorry I'm not there with you today, but we are going to continue right where we left off yesterday. So if you did not watch the video from yesterday, you need to go back one video and watch that, or this is not going to make sense because this is just a continuation of what we did yesterday. Additionally, there is a review up for your quiz. It is due and it will be graded, so that is due on Monday. So please make sure when you finish the homework for tonight that you also go forward and do that review that we'll be going over Monday. So starting off here, I see that I have a bunch of things that are fractions and one thing that is not a fraction. So I'm just going to go ahead and make that a fraction. And what stinks about all this is that they're all fractions. So I'm going to go ahead and try to get rid of all of the fractions in one shot. Now I need something that 8, 3, 6, and 1, all of them go into. So something that all of those numbers go into. And that number would be 24. So 8 goes into 24, leaving 3 on top, and there's still an x up there. 3 goes into 24, leaving 8 on top, and there's an x minus 2 still on top. There is a less than equal sign. 6 goes into 24 4 times with an x plus 1 on top. And then 1 goes into 24 24 times with that negative 1 still on top. So notice here that these things are still there. That x minus 2 is still there, that x plus 1 is still there, that negative 1 is still there. All those things are still there. But all we did there is we got rid of the fractions by finding something that all of those numbers go into. So what we're going to do now is just work this out. We get 3x minus 8x plus 16, that's me distributing that negative 8 to each of those, is greater than or equal to 4x plus 4, again distributing, and then 24 times negative 1 would be negative 24. I'm just going to see if there's anything I can combine here. We've got a 3x minus 8x, that'll give me negative 5x, plus 16 is greater than or equal to 4x plus 4 minus 24. Well, that 4x has nothing to combine with, but 4 and negative 24 will become negative 20. All right, from there, it looks like let's go ahead and subtract 4x from here, subtract 4x from there, and we get negative 9x. Let's subtract 16 and subtract 16. We get negative 9x is greater than or equal to negative 36. That's negative 20 minus 16. We're going to divide both sides by negative 9. Now that's an inequality symbol there. So remember, when we divide or multiply by a negative number, that inequality symbol is definitely going to flip. So we get x is less than or equal to negative 36 divided by negative 9 is a positive 4. Moving on to the next one here. We've got, again, 3 fractions. I'm looking for something that all 3 of those numbers go into. In this case, 6 will work just fine. So we get 3 goes into 6 2 times, and there's still a t up there. We've got 2 goes into 6 3 times, and there's still a 1 up there, is greater than, and now 1 goes into 6 6 times, and there's still a 1 up there. So we get 2t minus 3 is greater than 6. I'm going to add 3 to both sides, and I get 2t is greater than 9. Divide by 2, divide by 2, and I get t is greater than 9/2. Now I'm just going to leave it there. There's no point in turning that into a decimal. That's a great answer right there. If I did the division wrong, I might lose points, so no point in doing that. So here we've got 3, 5, and 1. I'm looking for something that they all go into. 15 would be a great number. 3 goes into 15 5 times, and we still have that x up there. 5 goes into 15 3 times, and we still have that 2 up there, is less than 1 goes into 15 15 times, and there's still a 2 up there. So we get 5x minus 6 is less than or equal to 30. I'm going to add 6 to both sides, and we get 5x is less than or equal to 36. Divide both sides by 5, and we get x is less than or equal to 36/5, which will not reduce. There is no common factor for 36 and 5, so we're just going to stop right there. Okay, last one for this page, and then we'll do some decimals. We've got 4, 1, and 2 as our denominators. So 4, 1, and 2 all go into 4. 4 goes into 4 once, leaving just 3x up there. 1 goes into 4 4 times, and there's still a 1 up there. 2 goes into 4 twice. Oh, sorry, I forgot my greater than symbol. 2 goes into 4 twice, and there's still an x minus 1 up there. So notice I'm just canceling out. 2 went into 4 2 times. That's where we got that 2 up there. 3x plus 4 is greater than 2x minus 2. I distributed there, 2x minus 2. So 3x plus 4 is greater than 2x minus 2. Let's subtract 2x from both sides. And we get x plus 4 is greater than negative 2. Let's subtract 4 from both sides. And we get x is greater than negative 6. Done and done. Okay, so for the next slide, we're going to see a lot of decimals, and it looks really crazy at first, but actually they're really not that bad at all. They're pretty easy. So if you notice on these, they ask us to simplify these. There are 3 things there, 1, 2, 3 different terms there, but each of them have those decimals. There's that 4 hundredths, the 12 hundredths, and the 7 hundredths that are all there. So if you notice, what makes that difficult is that part, those decimals right there. Now, one thing that we know about decimals is that, let's say I took the number 1.7 and I multiplied it by 10. Well, what that 10 does to it is it just moves the decimal 1 place to the right. So if I were to multiply by 10, it would turn a 1.7 into a 17. If I were to take 1.7 and multiply it times 100, it would move it 2 times to the right, and I would get 170. So if I want to move the decimal a couple times to the right, that's totally cool. I would just need to multiply by some number like that would move it to the right. Notice that this 0.04, that 4 hundredths there, if I could take that and move it 2 times to the right, it would just become a 4, which is great. And if I could take this one and move it 2 times to the right, it would be great. It would just become a 12. And if I could take this one over here and just move it 2 times to the right, it would just become a 7. So to move things 2 to the right, I need to multiply by 100. Notice it has 2 zeros in it. It moves 2 times to the right. So I'm going to multiply everything times 100. And when I multiply by 100, again, all that does is move things 2 to the right. So that 0.04 becomes a 4. That 12 hundredths becomes a 12. It's not going to do anything to these in parentheses there because that was all one term and we just applied it to the decimal. That 7 hundredths, moving it 2 times to the right, will just become a 7. And now it's much easier to deal with here. We've got 4x plus 12 times 800. Now I'm just going to go ahead and save you the time of working that out. I mean, definitely you would have to do these and check them, but 12 times 800 is 9,600. And then 12 times negative x is negative 12x. 7 times 800, well, I know 7 times 8 is 56, and then it's got 2 more zeros on there. Whew, a lot going on there. 4x minus 12x is negative 8x. And if I subtract 9,600 from both sides, I end up with negative 8x is equal to negative 4,000. Now we're going to divide by negative 8 and divide by negative 8. So we get x. Now those two negatives, they're going to become a positive for sure. A negative divided by a negative. Now if you're not sure how many times 8 goes into 4,000, do the division. Check it out. And you'll see that it goes in there 500 times. X is equal to 500. Now notice on this next one here for B, there's a couple decimals. There's a decimal here, here, and here. 3 separate things there. But this time, I don't need to move them 2 times to the right. I could actually get away with just moving them 1 times to the right, and then it would make them all whole numbers. They would no longer be decimals. So if I were to multiply everything by 10, it would turn this into a 27. It would turn this into a 5, since it's just moving 1 to the right. That's 5s, is equal to 12. So I'm going to go ahead and subtract 27 from both sides. And I get 5s is equal to negative 15. Divide by 5, divide by 5, and we get s is equal to negative 3. That one wasn't so bad. 2 more. Okay, on this one, again, I've got 3 decimals. Notice that in each case, if I were to move the decimals twice, it would solve this problem. There'd be no more decimal. So to move it 2 times, I need something with 2 zeros. I'm going to multiply them by 100. That 14 hundredths becomes a 14. That negative 6 hundredths just becomes negative 6. And that 15 hundredths becomes a 15. Well, that's kind of nice there. So I'm going to add 6 and add 6. And I get 14x is equal to 21. Divide by 14, divide by 14. That is a fraction that can be reduced because 7 goes into 21 3 times, and 7 goes into 14 twice. So we just reduce that fraction, and we get 3/2. Last but not least, this one right here. Notice that there's not 3 decimals. There's only 2 there. But the 2 that are there need to be fixed. To get rid of these, we would have to move them 1 times to the right or multiply everything by 10. Now, we can't just pick and choose what we're going to multiply by. Everything has to be multiplied. Well, that u times 10 would just become 10u. There wasn't a decimal to fix there. But the second one, that 4/10 will become a 4 minus 5/10. Well, that 5/10 will become a 5, and then it's got a u on it there. So it just moved the decimal over on the 2 that had decimals, and the other one just became 10 times u. All right, so let's add 5u to both sides. And we get 15u is equal to 4. All right, from there, we're going to divide by 15, and we get u is equal to 4/15. Now, they don't share a common factor. The factors of 4 are 1 and 4. They don't go into 15. 2 and 2 don't go into 15, so it looks like just u is equal to 4/15. And that's it. So make sure that when you are done with the 4-6 homework, that your next step is to go on to doing the review, which is also due Monday. It is definitely going to be taken for a grade, and we're going to be going over that on Monday so that we have 1 day before our quiz. All right.